Okay, we're in Module 2, Lesson 3, Find and Apply LCM and GCF. The I can statement is I can find and use the GCF or LCM to solve problems. And remember, we did this the last week, and we did tic-tac-toe to find these things. So let's look at number 1. 3 runners leave the starting line at the same time. Lena runs each lap in 3 minutes. Aria runs each lap in 5 minutes, and Tran runs each lap in 6 minutes. When is the first time in minutes that all 3 runners will cross the starting line together? Let's look at our first vocabulary word. You have seen that a multiple of a number is the product of the number and any whole number except 0. A least common multiple, which is the LCM right here, is the least number that is multiple of 2 or more given numbers. So how many minutes does it take Lena to run 12 laps? So in 12 laps, if we look back up here, she runs that in 3 minutes. So 12 times 3 is 36. We're going to complete the table. So lap 1, we're going to do Lena first. So 3, 6, we're counting by 9s. Or not 9s, I'm sorry, 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Over here, we have Aria runs each lap in 5 minutes. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And our last one, Tran, he runs them in 6 minutes. So 6, 12, 18, 24, 30, 36, 42, 48, 54, 54, and then 60. Now, if you're wondering how I got those, you really need to be practicing your multiplication tables, because on this one, I just did multiples of 3. This one, 5. This one, 6. Let's check them out. So you use the time it takes each runner to run 1 lap and multiply by the number of laps to find the time it takes each runner to run the number of laps listed in the table. Let's look at C. Look at the results in the table. What do you notice about the times in each column? They are factors of the times it takes to run, dividends, or multiples. They are multiples. Each time in minutes is a multiple of the time it takes to run 1 lap. Choose which sentence about the 3 runners' times is true. The 3 runners have a time of 6 minutes in common. They have a time of 15 minutes, 30 minutes, or they have no time in common. So let's go up here and look at this. We have 30, 30, and 30. So they have 30 in common. The first time in minutes that all 3 runners finish a lap at the same time is the least common multiple of their times. Use the table to complete the sentence. So 30 is the least common multiple of numbers in order from least to greatest. So we counted by 3, 5, and 6. Okay, let's head on to the next part. Okay, we're on Step It Out. So we have 24 granola bars and 16 water bottles. Taylor and Jake are in charge of bringing snacks for their chess club. They have 24 granola bars and 16 water bottles. They want to set out the snacks so that the snacks are distributed evenly in snack packs with no granola bars or water bottles left over. What is the greatest number of snack packs that Taylor and Jake can make? Here's our vocabulary. You know that a factor is a number that is multiplied by another number to get a product. The greatest common factor, which is the GCF, is the largest common factor of two or more numbers. So we're going to complete the table here and complete the table to find the possible numbers of snack packs and number of granola bars in each pack, or in each snack pack. So if I only have one snack pack, there can be 24, all of the granola bars will go in the snack pack because there's 24. I have 2 snack packs, that means I'm going to split it up in half. So I have 12. If I have 3, that means it's going to be 24 divided by 3 is 8. If I have 6 in each of them, 6 times 4 is 24. If I have 4 in each, that would be the opposite, so 6. 24 divided by 8 is 3. 24 divided by 12 is 2. And if there's only 1, that means that there'd be 24 snack bags. So the number of snack packs multiplied by the number of granola bars per snack should equal 24. The total number of granola bars. So each row must have a product of 24. Like we have 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24, 6 times 4 is 24, 8 times 3 is 24, 12 times 2 is 24, and 24 times 1 is 24. Now we're going to do it with water bottles. If I only had 1 snack pack, I'd put all 16 in. If I had 2 snack packs, I'd need to split it up separately. So 2 times what is 16? And that is 8. Then 4 times what is 16? That is 4. 2 times what is 16? And that's how we're going to get 8. And 16 times 1 would be 16. Yay, we did it. The number of snack packs multiplied by the number of water bottles per snack pack should equal 16. The total number of water bottles, and that's what we did. So in the first table, the numbers of snack packs and the number of granola bars per pack are factors of, so we'll get, it's going to be 24. In the second table, the number of packs and water bottles of the packs and the number of water bottles per pack are factors of 16. Using the information from the tables to list all the possible numbers of snack packs for each item, arrange the numbers from least to greatest. So on this one, we have 24. So 1 times 24 is 24. That's not where I wanted that one. Ooh. There we go. 2 times 12 is 24. I cannot go that far down. Hold on. So I have a 2 here and a 12 down here. 3 times 8 is 24. And 4 times 6. Make sure it's taking me so long because I need to get them in order from least to greatest. So make sure you do that. For water bottles, to get the 16, I have 1 times 16. So I have 1 times 16 here. I'm going to see if I can figure out how to do it without them having a hard time getting up there. There we go. Ah! We have 2 times 8 and 4 times 4. So apparently it's not going to let me drop my 1 up here.